Welcome to Desktop Estimator tutorial. To start with, this is the start screen for the takeoff program. We have a workbook menu. We have a job information sheet where you would fill in all your information for the job specifics, your builder, your date that you're doing the takeoff, your job name, the community, the estimator, plan date, and so forth, architect, engineer. We also have a takeoff quantities page. This page is the page that you would put your takeoff information, usually bring it in, import it from your takeoff program. Program I use automatically exports into an Excel format, and that Excel format that they export would be put into here, and this is broken down into the name, the description of the item, so forth and so on from the takeoff program. Going back to the workbook menu, we have 6 takeoff sets, 1, 2, 3, 4, 5, and 6. Under each takeoff set we have a series of takeoff items that we can do. These takeoffs are assemblies. So if we start, we have a stem wall footing assembly for the first one. To open the tabs at the bottom, we choose from the drop down, choose yes, and that automatically brings in the tabs that are going to be needed to do the takeoff and view the purchase and work orders for each one. So if we start doing the takeoff, we have a worksheet. Start with the worksheet. We have this broken down into 4 different categories: continuous footing assemblies, spread footing assemblies, CMU foundation wall assemblies, and cast in place wall assemblies. Is going to be a different footing. So for instance, if we have an F1 footing, which is the designation on the plan, we would put F1. Then we put the criteria for that footing. We have footing dimensions, then we have continuous rebar, we have trans rebar, we have stirrups, we have the concrete, and we have the dowel information. So let's start putting the information in. The width of the footing is 30 inches. The depth of this footing is 12 inches. We have 121 lineal feet of footing that was taken off either manually or by using a takeoff program. The rebar in this footing, the continuous rebar, is number 5, and we have 3 of them. The trans rebar or transverse rebar is a number 4. The spacing on that is 24 inches on center. The length of the trans rebar is the same width as the footing. That is a default value. We don't change it. We leave it in there as waste, but you can make that change manually. Now we have stirrups. If there were stirrups on this particular footing, there aren't, but if there were, we would choose the size of the stirrup. We would choose the stirrup clearance from the edge of the concrete, which usually underground is 3 inches, so the default is 3 inches. And that calculation is used to calculate the size of the stirrup. We will go into that, and I will show you that later. The stirrup spacing would be what they are in the spacing of the stirrup. Then you enter how many corners, 90-degree corners, there are for this footing. This will give you your pre-bent corners, which would be the same size as your continuous rebar. Then you choose the concrete PSI. You choose if you want a pump or if you don't want a pump. If you don't want a pump, you choose NA. In this case we chose a line pump, but you can also choose a boom pump. Then we have dowels. In this particular case we have number 6 dowels. These number 6 dowels are going to have a ratio of 1 to 5, 1 foot to 5 foot each leg. The spacing of the dowels is 32 inches. This calculates the dowels, and then if you want forms, you choose whether they want rent forms or wood forms, or NA if you want no forms. This now concludes that footing assembly. If we go to the purchase order, we see that we have the information that we need. We have 21 12-foot 2x12s for the footing forms. We have the rod chairs. We have 12 yards of 3,000 pound concrete. We have 8 number 4 by 20 feet. We have 21 number 5 by 20 feet for the continuous. We have 18 corner bars. We have rebar caps for the dowels. We have the dowels, 12 inch by 60 inch. We chose 1:5 ratio. The loop ties, and we have grade stakes that we put in here so that you could do grading. If we go to the work order page, this is going to show you your labor for this footing. We have a one-time setup fee. You can change that to whatever you want. If you want more, you can put in more. The unit cost for the setup, if you charge $500, let's say, to set up a foundation, you would put that cost here. Your F1 footing, you have 121 lineal feet of it. You put in your cost per lineal foot to install that footing. That would include all aspects of the footing in this case. That would be any digging. It would be not setting the forms, but setting the concrete, setting the rebar, and so forth. Now we have 0.58 tons of rebar in that footing. Again, you could put a unit cost in here for the cost that you want to charge. Let's say $400 a ton to set rebar. You would put 400 in there. It would calculate out. Then you have, this is your forms labor. You got 252 lineal feet of forms. Again, you put a lineal foot price, and here's your 12 yards of concrete for your line pump, and you put in your charge for your line pump by the yard. So if you're paying $30 a yard for a line pump, you would put 30 at this point. We didn't take off anything for stem walls, so there is nothing in the stem wall purchase order and nothing in the stem wall work order. That concludes our continuous footing. Now we're going to do a spread footing. And a spread footing, we would put the designation from the plan here. So we have an F4 footing. This is not a bollard, it is a footing. We can also take off bollard information, and we will go over that in a different takeoff. So the width of this particular F4 footing is 6 feet by 6 feet. It is 24 inches thick. We have number 5 rebar. We have 6 going width and 6 by the length. We have 2 mats, one bottom, one top, and we have a number of pads. We have 10 pads. These pads have dowels. They have number 6 dowels, and there's 4 for each pad. The ratio of the dowels is 1:5. The concrete PSI for these footings is going to be 3,500 pounds. We want to choose a line pump for this, and we want to choose forms for this, wood forms. Okay, if you notice, the height of this footing is 24 inches. So the wood it's going to give you is going to be plywood, and it's also going to be 2x4s to reinforce the plywood. So you would build your forms that way. If you want to rent forms instead, you would pick rent. If you're going to use dirt forms, you would pick NA. That concludes our spread footing. So now if we go back to the purchase order, we see that we have adjusted our takeoff. Now we have 120 2x4s, and we have 15 sheets of ply form that we took. The 2x4s and the ply form are used in conjunction to build the forms for the walls for the spread footings. We still have 42 rod chairs. We have 12 yards of concrete for the continuous footing. Now we have the 3,500 psi that we picked for the spread footings, and we have 28 yards for that. We have still the number 4. Now we have 93 number 5 by 20 feet, 18 corner bars still, rebar caps for the dowels. We have 98 dowels now, and we have 2 bundles for loop ties. We go to the work order page and we see that we now have an F1 footing, which we took off as a continuous for 121 lineal feet. We went over that, and now we have 10 F4 footings. So if you have a cost for an F4 footing, you would put that cost here. It would calculate continuous footings and spread footings. Now we go to the CMU stem wall worksheet. In this stem wall, we're going to have an 8-inch by 2 foot 8-inch high stem wall, CMU stem wall. So now we have the height, it's 2.66 feet. The length of that footing, if you remember, we had 121 feet here. We have the same length for that particular stem wall. We need one course of bond beam, and in that bond beam we're going to have one, and we'll call it a number 4. If you had a header block other than a bond, instead of a bond beam, you would choose a header block. If you have 135 degree corners, you would put them there. That would give you the CMU you need to create that corner. If we had 90 degree corners, again, we had 6 of them, so we still have 6 corners. The block size we have is 8-inch. You can choose from 4 all the way up to, well, whatever's in this drop down you can use. Okay, so in this case we're picking 8. It is a regular strength block. We're filling all cells below grade, so we fill all cells. If you did not fill all cells, you would put no. This is where this spacing comes in. So your vertical spacing is 32 inches, for instance. And we had number 5s. If you had a CMU wall above, you would put yes. That would make sure that you have dowels high enough to get into that CMU wall. And that's what you would use if you chose no here. But being that we have yes, we don't fill this out. We'll leave it as is. So now that concludes your stem wall footing. And again, we're using 3,000 pound grout. Let's pick 2,500 pound grout. So now we go to the stem wall PO. Now you see that we have 297 regular blocks, 91 knockout blocks. We have Quikrete set up for 22 bags, rebar 7 number 4s at 20 feet. Your corner bars we have 6. Because we need these 6 bars for the 6 corners that we have, because we have 1 number 5 rebar in the knockout block. And your grout is 2,500. You have 5 yards. Go to the work order. We have the same thing. We have 366 solid count, so you get your cost per block and your cost for your line pump to pump the stem wall. That would be the conclusion of your stem wall footing. Going back to the worksheet, we're going to do a cast in place wall. So now this cast in place wall, you can put down a description again. So let's say that this wall is going to be a 10-inch wall, and it's going to be 2 foot 8 inches high. So we're going to use the same criteria that we used for the stem wall footing, but this case it's going to be cast in place rather than a CMU stem wall. So we have a 10-inch wide wall, 2.66 feet high. We have 121 lineal feet of wall. Now in this particular case, we have vertical rebar in this wall. It's a 10-inch wall, and we're going to have our number 5s at 12 inches on center. You notice that automatically calculates how many vertical bars you have. This is your horizontal rebar for the side 1. So you have side 1 you have two sides to a wall. If you're going to put your rebar in the center of the wall or only have one set of rebar, you use just side one. If you're going to have two sets of rebar, you would use side one and side two, and you have the option to make side two, if it's calling for different rebar, you have that option. So again, our horizontal rebar is going to be 12 inches on center. It's going to be number 5. So now as you see, we have 4 continuous rebar horizontal. Now if we had a side 2 and we had, let's say, for some reason we have a different rebar, we had a number 6. Now we choose number 6 and we choose number 6 horizontal, and again we have that. Now we have 4,000 pound concrete. We're using a line pump. We also have 6 corners, and we're using wood for forms. That concludes your cast in place stem wall work. This information is also going to be on the foundation concrete PO. So if we go to the concrete PO, now we have a new PO which incorporates the continuous footing, the stem wall footings, the pads footings, spread footings, and your cast in place wall. Your work order for all 3 of those is here. Your stem wall footing for your 8-inch block is there, and your stem wall work order is there. So that concludes your stem wall foundation video.